computer. So we didn't have a meeting last week because they told me they're going to come and install all my windows, and they didn't. And I'm still waiting for them to finish that up. But we're going to have the meeting today anyway. And the other thing, while I was just going upstairs to get something, something in my house was chattering, and the lights were flickering. So it's a good chance I'm going to lose power. But even if I do, this will be an experiment to see if since my computer, the monitor is not on UPS. So that's good. That'll be interesting. Yeah. Anyway, so if that happens, we'll see. Because I've got I don't have curtains on the window in front of me. If you look at my glasses right, yeah, you can see my windows that don't have curtains on. So I've got lots of natural lighting. So when the lights go off, that I could still do this, but I don't know how to get my. I could do that. Well, no, let's not screw around with all this. So anyway, if the power goes off, we may or may not end the meeting. So last time, which was 2 weeks ago, we were talking about one of the things I brought up was Bob had asked for pictures of the way Al had mounted his encoders, so he knew how to do it on his vehicle. And Al's got those little magnetic absolute shaft encoders where you just glue a magnet into your shaft and you put your little board with a printed circuit up to the magnet, and as that turns, it gives you numbers out, so you know what angle your shaft is at. And he was able to get that to not only measure the position between 0 to 360, but he figured out how to get the rollover, so he can now do a continuous measurement as he drives forward, or on his steering if the steering turns more than 360 degrees. So he's figured that out, how to do that stuff. And so I said, well, I'll just go to the index for both ROS Agriculture and the index for this meeting and just look up places where we're talking about this. And one of the first things I found was one where Al says, oh, I made gears for my wheels, and he showed a picture of a gear stuck on his axle and a little gear. Then he had a shaft sticking out of the back where he's going to put his magnet, and he made those with a 3D printer. So he was just showing a still picture of that. And then at that point I said, oh, so how did you make those gears? So he launched into how to use Fusion 360 and a plug-in to say, build me a gear. You tell how many teeth you want and maybe the diameter or something, whatever it is. He made his own gears, and then he went through some steps there and said, this is how you do it. So that was on that one meeting that I found. And of course, I don't have that written down in front of me. I'll try to come up with that later. And then while I was digging through the indexes, because on that same point, he showed that bracket. He says he will put his board on there. He will put a microcontroller on there. But he was not far enough along to show that. So I know there's multiple meetings where he would say, okay, now I built this 3D printed bracket, and so I can bolt the board onto there. So it's up against the back of the magnet. So here's the shaft sticking out, and he's got this little board that just sits close to the magnet like that. So he built this bracket here that would hold all those pieces. And so I'm sure there's several times where we went through that. Unfortunately, my index doesn't say, here, go look at this, because Al's talking about his encoders. So so sometimes it just says Al's talking about his lawn tractor. Then I have to figure out which meetings on that are the ones to do that. So I need to go back and work on that harder. So that's one method we have. An example of an encoder is that Al is using those magnetic absolute encoder modules, and you can get several different brands. The one he's using is not the one I ordered on Amazon. Yeah, I found some on Amazon for like $5 a piece or something. They're just little boards that you hook up, and I'm sure they work the same way. The ones I've bought are 12-bit resolution. When he has is 14-bit resolution. But anyway, the point is he's made that work, and we could document that on number one, just how the thing works in general, and then how he used 2 gears to attach that to his axle on his lawn tractor. And when I built this one, when I built Sammy 2, the mini tractor, it's on the back here on the wheel, on the axle. I've got a gear, but I just have one that's pressed on. And of course, my stuff is all oh, is that one? My stuff's in disarray, but I might have one. Oh, it's not going to be worth digging for, I guess. But anyway, I've got these gears at the surplus store, and they were like samples or something. So the gear itself was like a 3-inch diameter gear. I think they're 24 pitch gears, which means it's a relatively large tooth compared to some of them you can get. And I found at the time when I was putting this thing together, I found 2 of them that had a 3/4 inch hole, so I could just take the wheel off, just press that onto the axle on the transaxle I had there, and they fit tight enough. They went on, stayed there just great. So I went to my box of gear and found like a 1-inch diameter gear that had a 1/4 inch hole in it. I just screwed that onto a optical encoder, and just just on the vehicle. Then here's the gear on the axle, and I took the little one, just pressed it up against there. I just made a bracket to hold the encoder up against there, because these encoders I have look just like potentiometers. It's just that they got 4 wires. There's just 3 wires coming out. But the way a potentiometer mounts, where you drill a hole, you stick it through, and you put a nut to hold it down. That's the way these things work. So I just have a little piece of aluminum bracket that simply I drilled the hole through and got that right, and then some other holes that are bolted down to the frame, and that's the way mine work. So basically, I'm doing the same thing Al is doing, but he's using 3D printed plastic, and I just use pieces of scrap metal laying around to get mine to work. And he made his own gears, and I had gears from commercial gears from a surplus store. And the first thing that turns up on ROS Agriculture is Matt was saying, this is back at like the third meeting or something, and he's saying, oh, I could modify my lawn tractor, and I found these. And he went to the farm supply store and he found some sprockets, and so if you don't play with this, a sprocket looks like that. So it's just a round piece of flat metal, and then they cut the notches in for the chain to go on there. And this is a number 35 sprocket. He has a number 50 sprocket, which means the teeth are about twice as big on the one he has, twice as big or 3 times as big. And his had like 30 teeth on it. So his intention was to put that on his on the axle on his lawn tractor, because you can buy. He talked about buying a hub for it at the same place, and then he got these little proximity detectors that he bought somewhere, and I bought some smaller ones on a different place. But anyway, if you put the proximity sensor up next to the teeth, as a tooth goes by, the sensor turns on. So he was going to do that. And I don't know if, throughout the whole 2 or 3 years we were doing the ROS Agriculture, if he ever got to the point where he showed a demo of it actually working and showed us waveforms and so forth. So Al and I were talking before the meeting that we should set up a little demo like that and say, here's, if anybody wants to do it that way, they could show, take this sprocket, put it on your shaft, and then put the encoder, the sensor on it, and then either look at that on an oscilloscope or just your Arduino serial plotter. You could watch it, so you can watch the square wave coming off from that. So that's something we should do. And again, going back to index, I didn't find a lot more write-ups on that. I'm sure, every once in a while Matt would talk about doing that. I don't know if he showed his actual pictures of what's going on. So, but we could try to collect all the stuff. And I was trying to think what other methods. And then like two weeks ago, I was saying that I had ordered some encoder wheels and an arm. So what you do is you bolt an encoder onto this arm, and you put an encoder wheel on it, and this thing just rests on top of your tire. So as your tire on your vehicle is turning, it turns the encoder. So that's just a quick way. It's I'm going to call it non-invasive, because you don't have to get in to the the shaft on the axle and all this kind of stuff. And so the advantages is it makes it easy that way. You just mount it so it just rubs on the top of the tire, and it should work. But the disadvantage is it's possibly going to slip. Since it's a lawn tractor, you're going to have if your grass is wet, your tires might be wet, and that might be affect how well it grips onto the tire. And if you're picking up dirt and sticks and mud and whatever, that's going to build up on it too. But anyway, it just seems like a quick way to if you just want to, if you got a lawn tractor, or like in this case on mine back here, I could mount it on this one, and that way it's already got my quadrature encoders, and then put the wheel, so the wheel would ride on top of the wheel here. The little encoder wheel would ride on top of the rubber wheel, and that way I'd have 2 forms of quadrature, or 2 forms of wheel odometry coming in. And you could say, does this one work as well as that one? And if it is slipping, you could then find that out, so you can go back later and say, over time the numbers should be exactly the same. From, say, on this side, if it's on this wheel right here, my quadrature encoder is going to tell me Since it's got gears right onto the axle, it should tell you exactly, how many ticks it has moved forward. And the other one just rubbing the top of the tire. You can then later on take the numbers from the two and say, if I've driven 10 meters or 100 meters or all the way around the block, the two should be equal. They might be off by some ratio. One might give you 10 times the resolution of the other, but at the end of the day, you divide by whatever the resolution is, and those numbers should be the same if it's not slipping on you. So that would be another interesting way to do that. So let's see, as we are talking earlier, we should come up with all these different methods and then try to document each one, just for food for thought, if nothing else. So as I say, Al or Matt had the sprocket. You got the sprocket and the little sensor that watches the teeth go by, and that was the first method somebody came up with. And then I put the quadrature encoders on mine with gears, and Al built his little plastic bracket, and he's got this cute little printed circuit board and magnet, and then he's got gears set up like I do. So in order to get to monitor the shaft turning, it's one way is to put a gear onto that shaft and then have a separate gear to turn your encoder. And both basically my method and Al's method are the same. It's just that I'm using a quadrature encoder. It looks like a potentiometer, and he's got that little printed circuit board that just rests up against a magnet sticking out of the shaft. So that's another way. And then we got the encoder wheel stuff. If we test that out and decide if that'll work or not. And originally I saw Greenzie had that on theirs, where they had their very first stuff that they built. And I dug through a lot of stuff on YouTube and a lot of stuff on just Google until I finally found some pictures of their original lawn tractor, and you can see that yellow encoder wheel in the picture, but they'd never given me a close-up, so I couldn't tell exactly how it's mounted. But it turns out it looks like it's just one end of it's hinged. You just bolt it onto something on your frame, and then the thing just falls down and lays on the tire. It's also got a spring that comes with it, so you can get a little more tension that way. So that's another method. And something that people have speculated over time, you could take an IMU chip. So it's got the three-axis accelerometer in it, and just ignore the other stuff in it. But the accelerometer gives you the force of gravity. So as you got your board like this, as the board turns, you got the say one axis is measuring this way and one axis is measuring this way. So as they turn, the force of gravity, when you get this one pointed straight down, it's going to be whatever the maximum is, like 9.81 meters per second. And then when at this point it's 0, and then it's the opposite polarity on that. So by watching it, if you plot off the two axes on the accelerometer while you're rotating it like that, you'll see that each one will create a sine wave, and then you take the sine wave, because the sine wave is 90 degrees out of phase, just like a quadrature encoder. And you run some equations. I think there's an arctangent in there or something, but basically you can take those two numbers and it'll tell you what direction the thing is pointed. And the nice thing about doing it that way, you don't have to be on the center of the shaft. It just has to be, you got a wheel like this. Instead of being right on the center, right there as it rotates, you can stick it on here or stick it on here. It'll go around like this, and it's still the board itself is going through a 360-degree path. So you can just build a little board and put a magnet on it, just stick it on see it back here, and just stick it onto the wheel somewhere. Or since it has these bolts sticking out to hold the thing together, you can bolt it onto that. So anyway, we were just trying to come up with different thoughts on what kind of encoders could you use to make this stuff work. So we decided we should go through and make a list of that, and then say, do we already have anything that exists? And if not, we could set up some kind of little test platforms to show this kind of stuff. So that's essentially, it all started off when Bob says, can you show me pictures of how to mount this? And I said, oh, just go to the index and pull up stuff. And it turns out there is, back when we got like 2 or 3 years of ROS Agriculture. We've now got 2 or 3 years of this stuff that we're doing. So there's lots of stuff out there. If it's just a matter of if you can figure out which videos to go watch, because then people will sit and they can actually show it to you, and as they're turning it or whatever. So it's things we've already done. If we just find a list of that, so you can just go look at to see how to do that kind of stuff. And we can always make a new one saying, well, we looked at the old stuff and this is what it's not telling you, so that we could just go through, pick a technique and go through and say, this is what it's doing, and then say, now you see how to mount it and how to make it work. Now here's what you do with the data once you've got it. So that seems like a worthy goal if we actually get around to doing that. So I don't think I have anything else. Let's see. Did I complain about my windows? I think I did. And I didn't actually do anything on my lawn tractor. I'm just sitting there looking at it. I was holding those little roller things up and saying, can I get it to fit under between the fender and the tire? And I think I've got 4 inches there, and my encoder wheel like 2.5 inches in diameter. So it looks like I could do that. So it's gonna be a matter of just trying it someday and go out and say that this looks like it'll work. Pull up my drill, start making mincemeat out of my the fenders on my lawn tractor and see if I can get that to work. So I think that's all I have right now.
Check out the first link I put in the chat and see if I just Googled number 50 sprocket. It looks like it's smaller in diameter than what you were suggesting, but it was just a frame of reference. I also put a link in there for a inductive proximity sensor. I don't know if it's the exact one.
Yeah, on the sprocket, if you go search for it, you just say if you say 30 teeth instead of 13 teeth, and you get the size of the one that Matt had. And he looked at on the shelf. You go to the farm store and you got all these stuck up on the shelf, and he just picked one he thought was about the right size. And the ones he was buying did not have any kind of a bearing or a hub or anything in it. It was just a big hole drilled in it. So then you have to get the separate hub, which is laying there. So that way you get the hub that fits your shaft, and then it's a standard size hole in the sprocket. So you stick the sprocket onto this hub and tighten it down, and that puts the whole thing together. But yeah, that's just for looking at it, that's a good example there. And I also thought if I go out to Google and say, show me sprockets, and if you can find a picture that shows say a number 25, a number 35, a 40, a 50, a 60, all next to each other, then you get an idea of how big the teeth are on these things. So that'd be another if anybody wants to look into this, that's what you can look at. And I'm not sure everybody should run out and start buying these parts right now until somebody actually gets something that we can try it and say, is this going to work or not? But yeah, that's good to see a reference here. Let me look at your inductive sensor here. It's these might be kind of like what I have. The sensor that Matt had looked just like this. Here, let me.
I think his had a yellow tip. This one has a blue tip. And there's a link for 50 tooth sprocket too, just FYI.
Yeah, as I was saying that and say, oh, you can see from this, and I realized that, well, it's in order for people to see it. How do I do this?
Because the one that I messed around with, just the induction part is different size. So you can see one of those is probably 3/4 or an inch, and the other one is half an inch or so.
Yeah, in fact, the one I have might be even smaller than that because I bought them from yet a different place. But when you look at them, I think the diameter of that will make a difference on. You probably want to match the size of the teeth on whatever you're looking at to the size of the end of that inductive pickup. And I haven't tried any of it, so I don't know if that's actually true or not.
Oh, look at that! When I was messing around with it, I fought with a blue pill to get it programmed. You know
Yep.
how to do that blue pill stuff. I can't get that STM, those things to work very well. But
More or less, yeah, speaking of those all the little boards, I found that some of them you can get the Arduino IDE to work with them, some you can't, and some will work, but you have to do a lot of screwing around. And a lot of the time, since it was an ST microcontroller, I would just give up and go back to my big development system, write the code, and download directly to the board and not use the Arduino stuff. So again, that's another whole can of worms that somebody could go through sometime and say,
definitely a can of worms.
here's what you got. You may or may not be able to program this with the Arduino stuff. So anyway, what I was trying to do, I was talking about the sprockets. I thought, oh, well, let me share my screen. So let me try this again. So I did a share screen, and it was up at the top. And every time I try to go up to move the move the thing around up at the top of the screen, Zoom says, "Oh, here's all your options," and pop up all these options, and they're in my way, and I couldn't grab the top of the box to move it. Let me try this again. Okay, so uh, so up here you don't see it, but when I move my cursor up to here, well, now it's not going to do it. So now I can grab it and move it, but every time I'd be down here and every time I'd move up, there it's popping up, which you can't. I'm sure you can't see that, but then it's putting this whole list of control options on top of where I need to grab the screen. So I think what I just did was
I'm seeing a ocean view with high cliffs and lots of files on a
you,
desktop.
you're not even seeing the share. Oh, I hate computers. Anyway, let's say it's not going to work. So if you go look at those links, and we'll post those in the chat. Let's see, it says one new. Okay. Yeah. But your point is, depending which sensor you have, the ones that Matt had were yellow, and then I see you had one that was yellow and really big, and you had a blue one that was smaller, and I have some that I think they're about a 1/4 inch diameter on that tip, and somebody should figure out, hold that up next to something and say, does that make a difference? It could be, if you look at the documentation, they'll tell you, like a radial pattern of how big of thing that can detect, or it might just be easiest to experiment with it. So if you got some sensors, put them up next to something, put them up next to a screwdriver or a sprocket if you have one, and see how it acts, and try to determine if, the size of that tip, does that affect how it's going to work? Because you might, if you're going to use the big sprocket like Matt had, you might have to get the one that's got the big tip on it, and then you've got the smaller sprockets like I had, you might have to get the sensor with a smaller tip in order to make it work. But I don't know. That's just speculation. I've never actually tried that.
And not that I mean, you're not going to probably find a sprocket made out of aluminum, but is it just ferrous metal so it wouldn't pick up aluminum?
I
Do you
believe
know?
that's true. I think they tell you that it is ferrous metal that you should use with this, but I'm not sure. And there may be something, because aluminum will, if you put an AC current through it, or AC magnetic field, it will generate eddy currents and do all kinds of fun things. But I've never looked into that to see what it would take to sense that. So I would say, yeah, get a steel sprocket if you're gonna try to do that.
Hmm.
Oh, the other point was, so the Greenzie started off, they were building lawn tractors. They had what they called the 0-turn lawnmowers, and they just put those encoder wheels on top of their wheels, like I was just talking about. And I just ordered the parts to do that. But if you go look on YouTube under Greenzie, they'll say, "Oh, here's the version 1 and the version 2 of our wheel encoders." Well, it turns out those are something totally different. So I think what they did, they bought a lawn tractor from somebody, and if you pop the wheel off, it's already got some kind of like a steel, like a gear in there, and then it's got some kind of a little circuit board that rides next to that, and it gives you the quadrature encoder off that. So it's quadrature, but instead of being optical, it's got some kind of magnetic thing that picks up the teeth on the gear going by. And then the version 2, I didn't see what the difference was, but they've got a video that says, how do you replace your version 1 with the version 2? And they say, pop the wheel off, pull these gears off, put the new gear on, put the new board on, and put it back together. But so all of that is beyond that original encoder wheel that they were using. So that is something else. Because probably, if you look at automotive stuff, like on your wheel, so you have anti-lock brakes, it's probably got some kind of like a metal encoder wheel in there, and some kind of a pickup sensor for that. So that, possibly you could get automotive parts and mount them onto, your lawn tractor or whatever you're trying to use. And every once in a while I think about, say, what about these people with a full-size farm tractor? Well, I don't know what modern tractors look like, but all the stuff we had the old John Deere A and John Deere B, and you look in the back, the axle was like a 3-inch diameter shaft coming out both sides. Then you got the big wheels bolted on. So I'm thinking, how would you, if you wanted to get the wheel encoders off from that, how would you do that? Because you'd have to get, if you're going to use a sprocket or a gear or something, you'd have to get something that would have a 3-inch hole through the middle of it, and then it would have to be big enough around that you can put another gear on there to run your encoder. So that's yet another problem, and that's one place I think, well, if you had those encoder wheels, that's just a rubber wheel that rides on something, maybe you could just have that ride on your 3-inch diameter shaft and be able to pick up the rotation of that. So, but that's just more things to run into. Or I, did I did I mention on the recorded part about the using IMUs, or was that before the meeting?
You haven't recorded that.
Okay, so the other option you could do is you get people have speculated with this over time, where you could get an IMU chip, and the IMU got, say, a 3-axis accelerometer, and the accelerometer is not measuring magnetic field; it's measuring the force of gravity. So gravity is always pointed down, or is it pointed up? Whichever way. Towards the center of the Earth is it gives you the maximum value, and inside your IMU you've got one accelerometer this way and one this way. So as they rotate, it gives you a 90 degrees out of phase. It tells you how much force of gravity you have. So when you're pointed straight down, it comes around and pointed straight down, you get like 9.81 meters per second. And you point it up, then you get negative 9.81, or maybe the polarity is the other way around. But as the thing turns, if you just watch a single axis as it turns like this, that'll plot out a sine wave if you watch it on, say, a scope or your Arduino plot stuff. And then if you got two of those like this, they're 90 degrees out of phase. That's just like the like magnetometers work, where you take the two axes and you run some kind of arctangent between the two, and it'll tell you, it generates a vector of what direction it's pointing. So theoretically, you take an IMU and figure out some way to mount that to your wheel. So either just put a magnet on it and then stick it on the inside of the wheel somewhere, or even stick it on the outside of the wheel, because it doesn't have to be centered. It just has to be, the board has to go through a full rotation for that to work. So that would be another. So if you have a full-size farm tractor, you might want to do that. Just slap something on the wheel somewhere, and as the wheel turns, and especially if you get like an ESP32 that's got built-in Wi-Fi. So you take an ESP32, hook it up to an IMU chip, and have a magnet or something, stick it onto the wheel. And so when you turn the thing on, it just connects to the Wi-Fi on your vehicle, and you got a completely wireless solution there to do that. But I've never actually tried that to see if that's going to work or not. And people have speculated that it should work, and it depends on how noisy the IMU is. If you can, because it is going to be noisy. It's going to be picking up all the vibration on your tractor, and you bump it, you're going to get all that stuff. It's just that the force of gravity is way stronger than everything else. So theoretically, you could just filter out all this vibration noise, and then you might be able to get good values out of it because of that. So somewhere along the line today, I said, well, we should make up a list of all these different kinds of encoders, and then ask anybody else, can you think of any other kinds, and just at least make a list of them, maybe write down what the pros and cons are, maybe try to do a demo of each type, just so so we can write that down somewhere and just refer people to it. So that's all I got, I guess.
Those are good ideas. On the IMU and on a wheel, the thought occurred to me. I mean, because a farm tractor is in terribly rough terrain typically. You could put it inside the wheel and charge the battery through induction. So the only thing that would be exposed outside would be some sort of apparatus to charge a battery inside with hopefully induction. But anyway, hold up your wheel with the gear, if you wouldn't mind, please. And so
Yeah,
turn it around so the other side is showing.
like that, you mean?
No, the other side without the gear.
Just the wheel?
Yeah, so I saw somebody take, like, they cut it out probably on a plasma cutter or something, small teeth, just square teeth, and they welded it to the outer edge of that rim. So,
Okay.
and then they put so the wheel is here, it's got this round toothed thing to the edge of the rim, and then the induction sensor was at the top because, again, if you're running through weeds or something, you don't want to knock something off that's down around the axle. And axles are terrible about wrapping weeds around them. But anyway, that was another idea.
Yeah. So that's a point that, as you say, you can use different types, and then part of that has to do with how much resolution do you want out of the thing. So if you've got, just a disc on here with, say, maybe 10 teeth, that's going to be a lot lower resolution than if you have something that's got 1,000 pulses coming out of it. So you got that, and then, as you say, to make it rugged, it's for what I'm doing. I'm just experimenting, driving around in my yard. I don't really care that much. I guess if I started doing actual mowing, yeah, you're gonna pick up a lot of weeds and stuff, so that might tell me. But
Anyway, let's see on my side. Just get screen sharing going here. What happened to my computer decided to go quiet. A couple of things to talk about, some IMU work and some speed testing work. This is plot juggler data from a bag file. I was trying to drive my lawn tractor at 0.5 meters a second. These were the results. It was tolerable, I would say, but it's certainly still needs more refinement, tons of things that are not right. The only data that's really worthwhile to look at that is this is where the mode where this is at 2, that means it's in auto mode, quote unquote. And so back to the speed from that point to that point. Well, that doesn't make sense because over here it's got target speed of 0. Huh. I have to look at that. Why would they have target speed? Anyway, so for a little bit of this time period, it was controlling the speed reasonably well. These are the values that the servo was getting. And this is just an arbitrary scale being sent to the servo to say more power or less power to the hydrostatic transmission. And that's the PID driver behind that is what I've been putzing around trying to get under better control. So still more work, but not, it was tolerable. And the result, this is ODOM look ahead data, which is the nice straight red line, and the blue line is the actual performance. You can see there's a constant offset here, although the line is reasonably straight, there's a constant offset here. So I've got more steering tuning to do as well. So back to my list of issues. There was a spike in speed when RTK drops. I've got, this is code called ODOM from wheel and GPS, which basically creates the ODOM statement. And it tries to use GPS data as much as it can, including the speed. But if I drop fix, then I'm trying to use the linear velocity from the wheels. So must have something going on with that calculation as to why I'm getting my spike. So that's something to look at. Jump ahead data, it's not really speed related, but as you look at this plot juggler results, you see this look ahead jump backwards for some reason. I need to sort of understand why it did that. It's probably not a huge problem, but certainly it's an anomaly that needs more investigation. As I mentioned, the offset between ODOM and look ahead. Getting that to be what I would like to have is, sort of an S wave going over that look ahead as tight as possible, but not there yet. But I wanted to get the speed moderated so that I could sort of rule out speed issues for this steering precision. And then minimum servo value of 300 back to my plot juggler data. The way the hydrostatic transmission works is you've got to give it enough pressure in order to get movement. But when you're going downhill, you don't want it, you want to be able to pull back. You don't necessarily need to go all the way back to neutral. Neutral is down here, like right in here, I think. So I think I need to reduce this 300 so that when it's going downhill, it's not picking up speed, which is what was happening here. I don't have my IMU data here to show you what the angle was, but I could do that, which would be pretty cool. Let's see other issues that I know I need to fix. Well, that's it for the moment. Any questions on any of that before I start talking about IMU?
No.
So at the moment, I have one IMU on my tractor that was made by some company called Chip Robotics. The reason I got it is because they included a ROS driver with it, but the IMU was effectively a relative IMU. And by that, I mean, every time you start the IMU, it says, okay, I'm at 0 radians, no matter what compass heading you've got. And my hypothesis is part of this constant offset between my target ODOM and my actual ODOM has to do with having a slightly inaccurate heading. And I say slightly inaccurate because what I have to do is I have to start with the IMU heading a certain direction. So I have in my launch file a default offset to give that. And so I don't think I can live forever with that IMU. So I've been looking at the, I, like probably most people messing around with this stuff, have multiple IMUs to play around with. So I've got, I'll stop sharing here for a second. On the top there is the Bosch. It's the Adafruit. You might be able to see the Adafruit symbol there, but it's the Adafruit BNO 085. A lot of people started off with the 080, which was fine, but this was a little bit more recent. Maybe they've got something even more current than that. So I've got a Arduino Nano getting data out of that, and the I2C pins hooked up. And I've been spending time figuring out which are they call them reports, but they're basically different data types that you can pull off of that IMU. And to build, let's get back to share screen here for a second, maybe. Come on, Zoom. Where did my share screen button go? Oh, there it is. So there is three, I'm going to call them record types. Again, they call them reports. Data from the gyroscope, data from what they call a rotation vector, and data from the accelerometer. And if I pull that data, I think I have enough data in order to build an IMU topic. And so that's what I've been messing around with to get that to work. And getting the data and displaying it isn't a problem, but I have at the moment I've got I call it chatter, like it's just um, it's making a ROS topic out of just an informational topic and publishing it instead of the full IMU message. So my IMU message looks like just a string of data just to see that it's working, basically. And so that's working. What's not working is if I upload my program and then start, I want that to go away. How do I make that go away? If I then start ROS serial, it hangs up at this statement and then starts repeating, unable to get to the data. Then if I unplug it, unplug the USB cable that's plugged into the Arduino Nano and then plug it back in, ROS serial is still trying to run, and then it runs and takes off. And then once I get this message, I'm golden. So I've got, I don't know, I think I'm going to start with adding a couple of resistors for the I2C because I don't have any resistors on this at the moment. And then if that doesn't work, I'll probably go down the path of putting in, I think you call it an NPN transistor switch on the IMU and drive that from the Arduino to turn the power on, so to get a clean, a clean start. So I don't know what's causing this. It's not booting both up the Arduino and the IMU at the same time and having it push data to the I2C and trying to get ROS serial to work. There's something going on there with synchronization. If you've got ideas, I'm all ears, but that's where I'm at the moment is I'm in the ballpark on PID testing for speed, and I wanted to get a constant or a better heading data. And I only have one GPS, so I could get the heading from the GPS once I'm moving, but what would really be sweet is to have two GPSs and get heading from that, but don't have that. Anyway, that's where I'm at. All problems Jeff is very familiar with.
Yeah, the problem you have where you hook it up and it's not working, if you unplug and plug something back in, it starts working again. Those are always real annoying to try to find out what's wrong with it and try to fix them. And then hopefully you get to the point where you just turn it on and it works. So because you only stack up so many of those problems before it just becomes overwhelming that oh, I got this whole list of things I got to do to make sure it's running.
Yeah, like I said, I'm hoping the I2C, putting resistors on I2C or giving the Arduino a couple of seconds to start before I power on the IMU will fix that. But those are my two hypotheses at the moment.
On the I2C interface, depending on which processor you have, and if you run an Arduino or something else, you can go ahead and you can say, set this pin, enable the pull-up resistor on this pin. So internally, you can put a pull-up resistor on those. Now, by putting an external one, then you know damn well that you got a resistor on then. So that'd probably be in the long run, that's probably the best solution, is just add your two resistors physically on the board somewhere.
And I'm not a double E guy. A 4.7 versus a 10K resistor. Any thoughts on those? Are the two most common that I've seen
Uh,
referenced.
I'd probably go 4.7K. Again, just the lower resistance value you have, probably it's going to ignore electrical noise better, but I don't know that for a fact. It's something I can believe, but until I actually go try it and somebody proves me that no, you're just an idiot. That's come up several times in my life where I'd say, "Oh no," say, "Oh, don't use tantalum capacitors because of this." And finally one day, I pulled out a book, came over and says, "Look, no, it doesn't matter." And I go, "Oh, okay." So he was very
Well,
nice about it, though.
I'm in the field of I just want it to work. So
Yeah.
two GPSs would be nice. Then you'd have heading all the time. Wouldn't be messing around. But then wouldn't have as good a data on the IMU on pitch and yaw probably. But
So of all those different GPSs you ordered recently, do any of those do the dual antenna type setup?
yes, I have one that has it will take as input two antennas, but I haven't other than getting it just sort of the hello world sort of functionality out of it. I haven't dug into it any deeper. So
And, and those, along with say IMUs or whatever, don't hesitate to put more than one on your vehicle. So if you've got say two IMUs you put on, you can go ahead and run them and then take the good data from one or the other. Whichever one gives you the best data that you're looking for, use that. And then like also on you're talking about getting the heading from the GPS, you can just add an extra GPS since you already have it, add that on there to give you the heading data, and then keep your existing one to give you your position or whatever.
yeah, that's a thought. I mean, now that I think about it, I think one of the issues on the dual antenna GPS was it was like a 5 hertz device. Um, and going back to getting the steering accuracy down, one thought is it will be improved if we have a higher hertz on the GPS update rate. But so that's part of the reason I didn't spend more time on it, is I wasn't gaining anything I was gaining heading, but I think I was actually slowing down on the location update, because I think I'm at 10 hertz now.
And that's why you might want to put two actual GPS units. So you got the position one gives you the faster update rate. And then if you got an extra one just to give you heading, then that one can be just a separate unit and just putting out, putting out something at a slower rate, but it's still you, number one, it gives you redundant data on your location. And then number two, it gives you the heading, the static heading all the time. So
Yeah, that's a good thought. Go back and head down the dual GPS avenue. Now the GPS units aren't exorbitingly expensive. I got multiple GPS units. Oh, but then I think I couldn't, like I've got a RTK correction data coming from the GPS brand name ComNav. You'd probably have to explain to me, how can I take ComNav correction data and inject it into a NavSpark GPS? I mean, that twists my brain.
as far as the heading, it probably generates all that itself. So you probably don't need a base station correction to get your NavSpark dual antenna system to give you a heading. So because one of its receivers is going to say, this is where I'm at, and the second receiver it's going to take the correction data between those two to generate a heading, I think. So that might work with no extra correction data into it at all.
Mm.
So that might be a quick thing you could try without having to do all the screwing around. Because the issue you're going to have, the NavSpark might be running L1 and L5, and your old stuff is L1 and L2. Well, the L1 data probably works in both places, but if one's got L2 and one's got L5, then they may not be compatible. And then it's a matter of, if you don't have that extra correction data, is that going to be, is that going to work against you? So I get it, just more things to look at and try to figure out what you need there. Look at it when the time comes.
One step at a time. Yeah, it won't be long before my servo shaft deteriorates to a point where it won't control speed anymore, but and then I'll be mucking around with speed servos. Okay, I'm done.
I think I'm done too.